Hi and welcome back to this series of tutorial. This is class 12, the second part of how to improve your simulation. So we've seen so far how to add variations and details into the simulation thanks to the emitters. And now, during this class, we are going to see how to further improve the look of your simulation with some forces and some masks. Okay, so go inside the DOP network. Here, the first thing we want to do is check that the division size is to 0.1 or something acceptable in your case for a fast simulation, because we are in setup mode, okay? So to add some forces and inside the simulation, I would like to first disturb the velocity to be able to get some interesting movement there and to add something beyond the actual emitter. So here, lay down a gas disturbance, sorry. And this gas disturbance here is really going to be plugged inside the velocity update because we are going to change our velocity. So we need to plug it here. Okay, so let's have a look here at how it works. This is the scale of the disturbance. All right, so this is the one you want to increase if you want to have more disturbance. The cutoff here is basically any values which are any voxels which contain values that are above this, okay, are going to be ignored. All right, and it's based on a field, a density field by default, which you can change, and you can see it here in the help on the binding tab. And here is a threshold field. Okay, so that means any density value inside the simulation which is above this is not going to be disturbed. All right, so this is important because this is where we define actually what is going to be disturbed or not. Okay, and here the block size is the size really of the pattern that we are going to use to disturb the fluid. All right. Now, if you go back to the bindings here, you may have noticed that we have a disturb field which is based on the temperature. Okay, which apply the disturbance to the temperature, and we don't want that. Here, I really want to disturb the velocities. So I'm going to go here and say velocity, and it's going to change that to vel. Now, the velocity is a vector field, so I'm going to change this to check this on. All right. Now, let's play with the default values, okay, and see what we have. All right, so we have something a little bit different than what we had before. All right, you know what? I'm going to do 2 flipbooks so we can compare them correctly. Okay, so maybe 4 flipbooks. So this is the reference one. This one has been made with a disturb scale of 0. Okay, this is the setup basically we've built all the way up to class 11. And now adding some disturbance with a 0.1 scale, this is what we have. And we start seeing some patterns appearing now here. Okay, and if I go for 25 or 0.25, now it's starting to be a little bit messy towards the end. And the last one is with a disturb scale of 0.1, and you see how crazy it goes. So it's really going to be about balancing these values on the disturbance, and then you can also play with the cutoff and the disturb size. Now you could also layer those nodes on top of each other to add some different disturbance at different levels. So for instance, this one I could say, okay, add some high frequency disturbance. And to add some high frequency disturbance, I need a block size which is rather small, so I can keep this one or go for 2 or 25 even. And I'm going to use the fringe of the density. Remember the cutoff, anything which is above this is not going to be affected by the disturbance. So anything below it is going to be. And below that, this 0.1 is going to be the density which is below 0.1. So all the transparency, the really, really thin areas of the smoke. And then I could add another one. So I duplicate this one and I say, this one you're going to act on the mid-range. You're going to do add a mid disturbance. And I'm going to increase the block size to 4 or 5, okay? because now I want a bigger pattern, and I want the disturbance to be a bit less important than the previous one. So I might go for 0.8. Okay, so it's not going to affect it as much, and it's going to make bigger patterns. And also, I want the cutoff to be a bit higher because I want to affect more parts of my simulation. So I might go for, no, too big, might go for 0.5. And then I want to go for low resolution, okay, sorry, a low frequency. And for the low frequency, I'm going to say, okay, go for a block size of 0.8, maybe even 1. And the cutoff is going to be 1 in this case, and I'm going to leave the disturbance like this. And then I just have to merge all of them together, okay? And they're all going to affect my simulation. Now, I changed a little bit the values here, and you can see that the actual low disturbance here is breaking up the main shape, okay, from what we had before. And then the mid and the low are in charge of adding some interesting eddies here and movement there on the other parts of the smoke, okay? If you want to compare that, let's compare with the first one. All right, second one, third one, this one was a bit too high. And now this is what we have. So if we compare the two, so you see that the shape, the main shape is broken up as compared to the previous two versions, okay? And then we have even more movement there than in those versions. Actually, this one is quite similar for the small patterns, so the mid and low res, but it changes quite a lot in terms of the low frequency. So the gas disturbance here is really disturbing the velocity. This is the disturbed field, the velocity, based on the density. So where I have a low density, or actually values of density lower than this cutoff, it's going to come and disturb my velocity only in this area. So basically the one that are quite transparent here. But what if I want to disturb my velocity, but according to the speed, according to the length of this velocity? So basically I would like to say, okay, where I have high speed velocity, I want to disturb my velocity field and add some interesting noise in there. But if I have low velocity, okay, the fluid is not moving so fast, I don't want to disturb it. And then there's no way to add here the velocity because the threshold field is a float field. And the velocity field is a vector field. Okay, so I cannot say velocity here or speed because speed doesn't exist. Well, we can't create it. And so this is what we're going to do. And to create some extra fields, go to the main branch here. This is where we have our smoke object. And lay down a scalar field. Okay, so as I said, here the gas disturbance is taking here a float field, which is a scalar. Okay, so we are going to create a scalar field as well. All right, this scalar field here, I'm going to give it a name, and I'm going to call it mask disturbance. Okay, mask disturb. That's the first thing I need to do. And now, I don't know if I can see it here, but if I rewind, maybe, I can't remember if we see it here or not already. Not here. And let's look inside the... so here, I never opened this with you. This is the geometry spreadsheet for the dot networks. And if I go... So we should have, what is it? Mask disturb here. Okay, sorry, I didn't see it. So now the scalar field is created. We need to give it some more information there. You see the division size, and center. We need to match the one from the main one, from the smoke object. So I'm going to copy the parameter, and I'm going to paste. All right, and then I'm going to, come on, I'm going to do the same here. Copy parameter. Paste relative values reference, and then copy parameter, and then paste relative reference. So now it's going to be the same field when it is initialized. But we also have a gas resize fluid dynamic here. And so we need to resize this field as well. And so we are going to say here in the extra resize field, I want to resize my mask this term. Okay. Now, I also would like to visualize it. So you can do a scalar field visualization here. All right. And we can show the guide geometry. And let's choose a color that we can recognize. So when it's there, we can actually see it. And then I'm going to use the smoke to be able to display it. And so now we have the field created. We need to put some values into it. Okay, and the values, we are going to create them at this stage, at this step of the simulation, pre-solve. We are going to prepare them before solving each frame. And so we already have the gas fluid resize dynamic. Actually, I'm going to call it resize just for the name. And then I'm going to merge it, merge something with it. And I'm going to merge a wrangle, a gas field wrangle. And remember what we said, we want the speed of the velocity, the length of the velocity as speed, and we are going to build the mask on this speed. So we need to create, we are going to say f at mask field, okay, mask, disturb. There, I'm a little disturb myself. Okay, mask disturb equals 1. All right. So we have full 1 values everywhere inside the container. So this is working. And now I want the length of the velocity. So length of v, and remember this is vel inside the Pyro solver, and I'm going to put that into speed. Okay. And now if I put speed here, now I have the values of speed inside my container. So you can see here we have some parts where we have 0, and here we have some really high values in the middle. Okay, if I can I actually use the smoke density? I can change this to have it exactly what I want, and I can remap the smoke as well if need be. But that's not what I'm going to do. I'm going to come here because I don't want to remap only the visualization of it. I want to remap the values. Okay, and I said I wanted to disturb only the high velocities, the really high velocities there. So I'm going to come here, and instead of doing mass disturb equals speed, I'm going to put it back to 1. Okay, and I'm going to do some algorithm in there, not really complicated. It's really basically a fit. Okay, so we are going to fit speed. Okay, between high values for me, let's say it's, I don't know, 10 and 20. And I want to mask this, so I want to do something between 0 and 1. All right? And this is what I'm going to put into the mask disturb. So I come here, I copy that, actually cut it because we don't need it here, and we go here and we say equal. Now, this is the speed between 10 and 20 that we have, and we are really fitting everything between 10 and 20 between 0 and 1. All right? Well, now I can come here to the gas disturb and say mask disturb. And remember this mask disturb here, the threshold field, is used with the cutoff. And how the cutoff is working, any value above, look here, higher than this in the threshold field, which is now mask disturb. So any value higher than 0.1 in the mask disturb is going to be ignored. So that means my field here, the mask disturb that I created, is inverted. Because here, any value above 0.1, which basically are value between 11 and 20, are going to be ignored. And so it's going to be disturbing the values below 11. And I don't want that. So what I need to do, I need to reverse my field. Okay. And now these are the values that are going to be cut off by the disturbance. And it's going to be disturbing the values inside this area. Okay. So again, the cutoff field here is only working on values below this value here, below this threshold, inside this mask, inside this threshold field. So if I go to this threshold field again, here, this is what I have for high-speed values, okay? Those values are going from 0 at 10 to 1 at 20, which means any value above 0, 1, above 11 are going to be ignored by the gas disturbance. If I do the opposite, if I do 1 here and 0 here, okay, now any value above 0, 1, which is basically above, so 19, well, below, because we are reversing it now, okay, above 0, 1 means all the value before this 0, which means all the value between 19 and the rest, okay, below 19 are going to be ignored, and all the value above it are going to be affected. And so if I put here now cutoff at 0.5, that means any value, where am I? Here. Any value between 0.5 and 1 are going to be ignored, which means any value between 15 and 10, or actually below 15, because below 10, we are actually also setting 1, okay? This is not, this is clamped to 1. Below 15, we are not going to affect any value, any velocity. And that's what I want. So I'm going to leave it like this. And here, I'm going just to do some color coding because it's also easier for us to know what is working together. All right, so I recommend you work like that as well if you can, just so you know that, okay, all those nodes are actually working together. All right, and so now I'm going to hide this. Don't want the, actually, if I do this, and okay, good. So I just have to deactivate this. And so I made 2 flipbooks. The first one with a scale of 2 and a size of 0.6 here. And I think the second one is with a scale of 4 and a size of 0.4 for the pattern. All right. And so you can see that it's changing really the animation without affecting all these areas here. If I pause and I come here and I compare the two of them, you see that this is more or less the same. Okay, but we affected the main movement of the smoke by changing the high-speed velocities, the one from the impact, and so we can have more turbulence now in this one as compared to obviously this one, which is a bit more quiet, if I may say. Okay, and then you can go even further, obviously, with this setup. One thing I should mention before we go any further, I did not tell you how to choose these values that you put into the mass disturb here, into the fit for the mass disturb. Here in the end, I choose 3 and 10 instead of 10 and 20. And how did I know about those values? Well, go to your smoke object here, okay? And you should display the velocity field, okay, the velocity information here. Then I hide my multi-field. I'm going to zoom here so we can see something. By default, the velocity field is using, hold on, it's not using the planes and it's using streamers, okay? And it's also here in infrared mode. All right, so you should have something closer to that. Now, what I did is I used the plane here, okay, to get my values. You don't have to, you could stay also with just streamers. And then I change this from white to red. This helps me basically see the values, see the values that I have in my velocity. And then here your visualization range, should be between 0 and 1 at first. And this is how I played. I said, okay, no, this is the entire velocity range. I don't want that, so I'm going to increase and reduce, okay? And here, I want to get my high values. So where do I get something which is actually not showing any red? Okay, it's above 20. So I want to affect those values, and so I increased here to get only the values that I wanted. And I ended up with values of between 3 and 10 because I wanted to affect these areas only. You could also go for 5 and 10, okay? And then you would have your mask here. You cannot use this directly, so I mean, this is just a visualization, but then you can use those values back there and decide, okay, use between 3 and 10 or 5 and 10 or whatever values you have, okay? So it's a good habit to take. and I should have mentioned it before, always try and visualize the data you are working on. Always try and visualize the minimum and maximum values you are working on. Okay, and this is one way, at least here, for the velocity. Now, another thing you can do to help you improve your simulation or actually control it better is to add what I call helper emitters. Okay, you're not limited to the objects you have in your scene to build your emitters. You could actually build your own emitter if you're not really happy with what you have. And let's say, for instance, I'm not happy with what the truck is giving me, the velocity the truck is giving me, because it's pushing the smoke in this direction, and I want it to come more towards the camera. Okay, so I need to build my own emitter with some custom velocities. And so here I'm creating a geometry, which I'm going to call helper emitter. Okay, and I'm going to dive inside and I'm going to merge, object merge. So my wall simulation, helper emitter, no, that's not the one. Okay, some wall simulation out. This is the one, and I want to freeze this at the first frame, so I'm going to use a time shift here of frame 1, hide this, and now if I display this, it's not moving it. And now if I come here, what I want is a fan shape in the velocity, and currently I have no velocity, okay, and actually I'm going to display my own vector here. And the way I want to build the velocity is by using some other object to assist me in this process. So I'm going to use, I would like a point, but basically to visualize, I can use a sphere in primitive mode. And if you look at the sphere in primitive mode, you see that we have a point at the origin. And this is the one I'm going to use. Now go to the 4-view mode. Merge these two. This is really for visualization purposes. Now I have my sphere here, and this is where I have my my fragments. Press enter, and I'm going to okay, I'm going to move my sphere here. All right, to where I want it. Oops, it's not the right one. I'm going to move it here. All right, now I should have it close to my point. I'm going back to this view, G, to visualize everything. And so, yeah, so I have my my sphere here, and I'm going to use it as the origin of my velocity, the calculation of my velocity. And so if I go here now and I create an attribute wrangle because I want to build my own velocity, I'm going to put this one here because this is the one on which I want to create the velocity. And here I'm going to use this as a second input. Inside, I'm going to define my velocity. So let's check it's actually working first. If I do this and close the bracket, enter. So we have some velocity. If I put 10 here, it's actually going along the x-axis, which is correct. And so I don't want that. I'm going to set this to 0 first. And then here I want to get this point information, the position of the point. So to do that, you go to a point, okay, and you get so it's the first input, well, the second input, so 0, 1, and you want P, and you want the first point, I mean the point number 0, and I'm going to put that into some in vector attribute at position or origin. At the moment, I'm going to use an attribute because I would like to see my value is actually correct. And if I go here, hide all attributes, hide all attributes, origin. All right, so it's, why is it not showing anything? Here I have my points. Okay, where did I? Okay, sorry. Now 52, this is correct. Well, it's roughly correct because I know the range where my my value is. So this is good. I can also check it here, obviously. So the origin is good. So I'm going to use that as vector origin. And now I want to define the velocity. Velocity equals my current position. Okay, the position of my current point here. Oh, I don't see. Yeah, okay, of course. The position of my current point here minus the origin here. So here minus origin. And this is what I have. And the thing is, now I have this. If I go on my sphere, why I'm not seeing it? My sphere, I can't see it. Why is that? Okay, so I'm going to do a merge. Fine. If you don't want it this way, we can do it another way. Oh, was it? No, it wasn't. It's fine. I'm going actually to reduce the scale to 0.2. And now if I select this and if I move it, then you see that my vector is actually changing. And the further I put it, the less fan shape I have, and the closer I put it, you see that it's going in all directions now. It's spreading even more. I can actually put some amplitude onto it. V add V times equal, let's say 10. All right, and this is what we have. Let's go back to it. And now if I remove it, then I close the cone. And if I increase it here, if I put it closer, then I increase the cone. And also it works with the height. So if I put it below, the vectors are going up. And if I put it above, the vectors are going down. And this is going to help me big deal in my simulation, because now if I want, let's go back to the camera, I could decide whether it's going this way or this way, if it's going to help the truck emission or not. And so this is what we used to have without a help parameter. So this is only the truck. And then I merge the help parameter with the truck, and we start having something different. And here I I removed the truck and I have only the help parameter. And you see that I can change completely the direction of the smoke at the moment of the impact. So you're obviously not limited to this kind of help parameter. You can build your own emitter any way you want. I just wanted to show you this so you know you're not limited to the object you have, and you can find any other trick to make your simulation look a bit better and have more control on this, because as FX animators, this is what we need. We need more control on what we are doing. I would like to show you something now that I think will help you when doing your simulation and wedges. Usually what I do is I tend to save my file as sim0102 with the version inside the name. And I want to use this version to be able to cache correctly my either my geometry or my renders or my compositing. So to help me in this, what I create is a geometry here. Okay, it's going to be an empty geometry, which I'm going to call control. All right, I'm going to color that so I know this one is going to be empty. And on this control, I'm going to get the number from the file name. So go to the parameter interface, hide all this, and I actually get it as string. All right, and then select this, and you can make them invisible. And here I'm going to say version and version, and I accept this. And now the game is to get this part of the file name, and I'm going to use a Python expression for that. And so Python expression S for string. Okay, I need to put that between backticks, and I need to say, okay, who dot I think it's hip file, if I remember correctly. I might have forgot this. Hip file, and if I do that, what do I have? Okay, nothing. Hip file dot base name. All right, so this is the name of my file here. And then with some cool Python method, I can just get this part here. So I'm going to split with the dashes here, okay? So this is where naming conventions come really important. So you might have a different expression here because maybe you have a different naming convention if you use underscores or dots or whatever. But this is the way I have to do it now because I have this naming convention. And I'm going to split with the dashes, okay? And this returns an array of values that are this one, this one, this one, and this one. Okay, so 0, 1, 2, 3. And basically I want number 3. So I'm going to say number 3. And now I have this, okay, because this is the last part. And then I need to split one last split, okay, with the dot this time, and I'm going to get the first part of the array. Oh, I need one bracket here. And now I have my version. All right, so good. I save that. All right, and then I go to, okay, so we could use this version here inside the dust here, okay, inside the volume, and we could cache that inside the animated with the dust volume, and there here we could insert the version, okay? And if I do that, then I'm going to have a new volume for every version I'm rendering. And then you're going to clutter your disk really, really quickly. So what I recommend doing is you simulate with this name, okay? So basically you simulate and you have your cache here inside this folder. And then you render, so you have your render here. And then you do your compositing, and your compositing is going to appear here. And then when you launch the next simulation, you overwrite this part here. That way you know that you always are going to use this disk space, and you are not going to use any more disk space. And then for the render, either you increase the version because you want to keep the render, or you overwrite the render. But here for the compositing, you keep new versions coming so that you can compare the versions together without increasing the disk space usage because of your simulation or your render. So I'm going to go here to the compositing network, and I'm going to add the version here only. And then we see how it works when I do some simulation. So here, I'm going to say underscore v, and I'm going to get the version from here. So copy parameter, get back here. Here in the middle, insert, paste relative reference. It's going to paste it for you. And then if you middle click here, you see that we have 01. But we are missing the fx comp. The $OS is not expanded correctly, this. This is because it works fine when you don't have anything behind like this. But when you have something behind, you have to use these curly brackets. Okay? Otherwise, it's not going to work. And now you have it, fx comp v1. And because I want to also put it here, I'm going to copy this, and with the v and the curly bracket, because I'm going to need them. And I'm pasting that here, and I need the curly bracket here as well. And now you have fxcomp v1, fxcomp v1. And so if I come here inside my top network, I'm going to save my file. I should have everything all the way up to here, yes, because I already have my simulation ready and my render ready. And so when I press Shift-G here, I'm going to have my compositing starting rendering, and it's going to appear here. And then you have the compositing here. And if I double click, I should have it. And then we have, well, we need to wait for it to start. Okay, so we have more frames here. Good. So it's working. I can close that. Here I have my fxcomp v1. So I'm going to save this as simulation 2. Okay, I'm going to check here my controller is actually correct. That's good. I'm going to change a few things here in my simulation. So I'm going to, let's say, put the track back and use the help parameter. Actually, I'm going to put the scale here of the track maybe like 3 times bigger. And I'm going to maybe increase the terrain emitter here and do 10. And the helper, I'm going, yeah, let's go here. And I'm going to put maybe, I don't know, something crazy, just so we can actually see that there is a difference between the two simulations. And so I'm going back here. Now here, be careful when you delete this, because it's going to delete the entire chain. And it might be deleting this because it still maybe have this previous version in memory because it's saying it's ready. So just in case, come here and say generate node. Okay, no, I think it's dirty selected node and generate node. Okay, now you see it's saying that it doesn't have anything at the destination folder. And now you can come here and delete selected node results from disk. And we should have this deleted. Okay, the simulation. Here, it deletes the render, but not the first 30 frame, as I showed you. And here, I still have my compositing with the video, which is good. And so I'm going to say I save and then Shift G to resimulate, render, and then do the compositing automatically. And so my new simulation is ready because I have here my comp v2, which I can see. So obviously the values are not the best for what I want, but I wanted to show you that there is a difference between the two simulations. So now if we look at comp v1, which is still available because it has not been overwritten, then we have this simulation. All right. And here we don't have any more information written to this. This one has been overwritten. So this disk space is the same as with FXComp v1. Okay, I didn't clutter my disk anymore. And here, same for the render. I have the same render. Okay, so this is my way of working. All right, so we have one file with a version, and then I use this version inside the compositing only so that I can keep, when everything is done, I can keep the compositing version, but get rid of the render and or the geometry. All right. And so I can compare my versions. And then if I say, okay, I want version, I don't know, 15, then I can just simulate again. That's the downside of it. You have to launch the simulation again when you're happy with one of the results, but at least you're not, you don't take the risk of filling entirely your hard drive, and then you cannot simulate anymore because you don't have any more disk space to write the files. You could also, if you want to keep the renders instead of having to recalculate the renders, you could also do the versioning with the render. Okay, this would be exactly the same, but instead of writing the version inside the comp file name, you would come inside the ROP here and write it inside this name. And so this concludes our class 12 about improving the simulation. So because you are going to do a lot of wedges and iterations with your simulations, I give you this, my workflow. There are many others, but this is my workflow. I use a version. I try to get the version from the actual scene, and then I use that to increase the compositing on disk and overwrite my BGOSC, the geometry for the volume. Then one thing I didn't mention, but I would like to recommend as well, is that inside your compositing here folder, you save the file along with the render and the video. Just in case you want to come back to it later, at least you have it with the correct parameters and everything set up correctly. And I also saved it here, as you can see. All right. And I recommend you do that for every iteration you do. So when you're at version 73 and then you say, oh, okay, I want to go back with version 23. What was the parameters? At least you have the file saved with the compositing. So we've seen as well that we can help ourselves with some help parameter. Okay, this help parameter helps us control better the emission of what we want, and then we can control the direction of the smoke or the amplitude. You don't necessarily need to use all the assets you have in your scene. You can actually create some of them that can help you. And we also have seen how to visualize the data with the visualizer so that you can get the proper range here of the speed in this case so that you can use it and create the mask correctly. All right. So that's it. Thank you for watching. And I'll see you in the next class. Goodbye.